Hello, everyone. Welcome to today's live broadcast, Eliminating Toxic Contaminants from Cannabis Extracts Using Proven Chromatography Purification Methods. I'm Meg LaRue, the Editor-in-Chief of Cannabis Science and Technology, and I'll be your moderator for today's event. We are pleased to bring you this web seminar presented by LCGC and Cannabis Science and Technology and sponsored by Sorbtech. Who is Sorbent Technologies? Established in 2000, Sorbent Technologies has specialized in products for chromatography and purification, assisting universities, government labs, and industry, such as pharma, biofuel, materials, food and beverage, CMOs, and CROs, with method development and optimization from analytical methods to full-scale process with both standard and complex chemistries. Sorbtech has provided solutions for small, large, and biomolecules, synthetic and natural products. The company is committed to helping chemists to identify and offer the most efficient, cost-effective solutions for their applications. Sorbtech provides the highest quality chromatography products: PLC plates, HPLC columns, GC columns, SPE cartridges, flash cartridges, bulk adsorbents, and other products for laboratory and production. We have a few important announcements before we begin. This webcast is designed to be interactive, and we encourage you to ask questions during the event. You can submit questions by typing them in the Q&A box, which can be found on the right-hand side of your screen. You can enlarge the slide window by clicking on the small green icon in the upper right-hand corner of the slide window, or by hovering your mouse over the lower right-hand corner and dragging the window to the desired size. The slides will advance automatically during the event. If you have any technical problems viewing or hearing this presentation, please click on the question mark help widget in the dock at the bottom of your presentation window. I would now like to introduce today's speakers. We are pleased to be joined today by Dr. Robert R. Kerr and David Schurer. Dr. Kerr has more than 30 years of experience in analytical instrumentation and the application of chemistry to finding solutions to biological questions. He serves as an in-house scientist, and his current goals are the application of a new form of chromatography. Dr. Kerr's expertise in separation sciences includes instrument development, conception, development, manufacturing, sales, marketing, and service. Dr. Kerr earned a BA from Austin College, an MA from the University of Texas at Austin, and his DEA and Doctor of Science degrees from the University Louis Pasteur. David Schurer co-founded Sorbent Technologies in 2000 and serves as the company's executive vice president, where he leverages a comprehensive background in laboratory and scientific supplies. Delivering more than 28 years of laboratory equipment sales experience, David works closely with the company's customer base and evangelizes Sorbtech solutions, ensuring concierge service and support to enable customers to achieve the greatest results possible in their research. He earned his BA in Business Administration from Emory University in 1979. Thank you both for joining us today. David, please get us started.
Thanks, Meg, for that intro. Good morning, everyone. Welcome, and thank you for joining us today. Our webinar, Successful Methods to Eliminate Toxic Contaminants from Cannabis Extracts, presents ongoing research that was started in March by Sorbtech because of the challenge for us to properly direct our customers in the optimal use of stationary phases such as fluorosil and silica gel, etc., for the difficult challenge to decontaminate cannabis extracts to meet state regulations. This research is being conducted by Rosa Beebe of A1 Extracts in Portland, Oregon, and directed by Dr. Robert Kerr from Sorbent Technologies and my fellow presenter. A quick note. We want to acknowledge that with an audience of widely varying backgrounds and knowledge of chromatography and purification, it's sometimes difficult to strike a balance between being too technical for some and not technical enough for others. We've tried to hit a happy medium with this presentation and hope that it will resonate with most, if not all of you. So, who is Sorbtech? As Meg pointed out, we specialize in chromatography products and purification and solutions since 2000. We are committed to providing the highest quality products, services, and the most cost-effective chromatography and purification methods for our customers. And for 18 years, we've helped chemists and universities and industry to overcome the difficulties to separate and purify their compounds. So why Sorbtech and cannabis? Well, for the past 5 years, we work with companies in the cannabis industry to assist in extracting high-quality CBD from hemp, in separating cannabinoids, providing analytical products for testing, and now in delivering solutions for the very challenging process of decontamination of cannabis extracts in production. So for over the past 2 years, as the cannabis industry has grown and become legal in more states, we have gotten daily calls from customers asking to help them in decontaminating their cannabis extracts. And as we are committed to offering best solutions to purification challenges, this decontamination issue has become a real challenge for us. And because there are no current standardized methods to utilize stationary phases such as silica gel, etc., for this application by the manufacturers of these products, we decided to begin research and testing with our own resources, our time, money, and connections to identify the best methodology. So although Georgia passed a medical marijuana bill in 2015, state law still bans growing, buying, or transporting cannabis. Because of the current Georgia laws, Sorbtech cannot do research in-house to develop methods and to optimize the use of different chromatography products for decontamination. So in March, we started working with a colleague, Rose Habib, and an established testing lab, Cascade Labs in Oregon, to begin the process of developing methods for decontamination. There is no silver bullet, let me tell you, none. And we are committing our own resources to discover the best route to take, or routes to take. So why this webinar? Well, simply because our customers are calling us daily for solutions to their decontamination problems. And decontamination of cannabis extract is very complex chemistry, and there is no current defined methodology. So first, we want to identify the best way to condition the extract to perform optimally on the selected stationary phases for maximum absorption of the contaminants while maintaining an efficient flow rate. And Bob will explain this later. Then we wanted to understand the absorption capacity of the different stationary phases for contaminants while maintaining the yield of the valuable cannabinoids, terpenes, and other compounds, along with the ability to recondition the stationary phase for multiple runs and longer purification cycles. Our focus is to develop an efficient and cost-effective, and I mean a cost-effective solution to decontaminate cannabis extracts to meet state regs, while minimizing any loss of yield of valuable compounds for our customers in the growing industry. Well, we understand there is no substitute for detailed knowledge, and we'd like to share that knowledge with you today. Sorbtech has significant expertise in natural products purification as well as the separation sciences, and most of our customers do not have this same breadth of knowledge and experience, and we have noticed that in the cannabis industry, systematic knowledge is more rare than frequent. And so what do our customers need, and the industry needs? They need to be, one thing they don't need is to be put through a maze to nowhere, as this slide shows you. And it's been very difficult when I deal with a lot of customers to help them with their problem. What they need is a reliable, efficient, and cost-effective methodology to decontaminate their cannabis extracts to pass the state regs while maintaining valuable yield of their cannabinoids and related compounds. They need to know what works and what does not work. And we at Sorbtech are going to provide this information using experimental data. So what we are presenting today is really episode 1 of the continuing saga of cannabis purification to remove harmful contaminants to provide safe products for the consumer while meeting state regulations. These studies are ongoing. There is no silver bullet, but there are several magic Dr. Kerr bullets. Now I'd like to pass the presentation over to Bob. He will dive into the challenges of eliminating contaminants from cannabis extracts, and he'll present the research and the valuable results we'd like to share with you today.
Hello, everyone. So starting with cannabis plant material, After extracting it and after distilling it, usually to decarboxylating it, but before any treatment, we had tested the material we were working with, and following Oregon law, which we're going to get into in a minute, 59 contaminants were assayed, and 49 were at either very low levels or non-detectable levels, and so the batch passed for those contaminants. But 10 contaminants were at a high level, and the batch failed for those contaminants and overall. So the batch failed. So, and this is a very common case. Now, this is a moderately contaminated lot with about 100 ppm of total contaminants. Now, these contaminants, I've added these so you can read them easier, were biphentonate, boscalid, spiromethamphetamine, trifloxystrobin, bifenthrin. That, by the way, bifenthrin is a very commonly used, widely used insecticide. Fenperoxamate, malathion, another widely used insecticide. Myclobutanil is heavily used as a fungicide. Pyperynyl butoxide, which is not a pesticide, it's a synergist that's co-applied with many of the pesticides, and the 6 natural pyrethrins, which are all grouped together. Now, if we start with the same plant material and extract and distillation, actually the same extract, after one of the treatments that I'm going to describe, we found that 59 contaminants were assayed and 58 were non-detectable. They were gone. So, but one contaminant, which is pyperynyl butoxide, it was still at a high level, and the batch failed. The batch failed overall. But we have a separate solution for that one. Stay tuned. We'll get back to that in a minute. So what follows in the rest of this presentation is why we did this, how we achieved it, and how you can achieve it. So now, just to state very clearly, our overall general objective is to eliminate toxic contaminants from contaminated cannabis extracts with simple procedures in a cost-effective manner. Doesn't matter if you can do it if it's too expensive. So the background to all of this is, though it is an agricultural product, the level of contamination of cannabis and cannabis extracts is effectively not covered by the federal regulations since it's illegal to possess it in the first place. However, the Federal Insecticide, Fungicide, and Rodenticide Act of 1910, commonly referred to as FIFRA, is still federal law for the United States of America to protect everyone, the applicators, users, consumers, and the environment in all products of any type. And so the toxic contaminants this regulates are pesticides, herbicides, fungicides, and synergists, which are used by growers for 3 reasons: to improve their crop quality, their yield, and increase their profits. So even with organically grown cannabis, we put that in parentheses, frequently some contaminants are found due to their use on crops in adjacent fields or remaining from previous crops due to biopersistence. So the toxic contaminants are found commonly found at the 1 to 50 ppm level per contaminant in the plant material. And the extraction processes for removing and concentrating cannabinoids also remove and concentrate the toxic contaminants. And usually the concentration increase is a factor of 10 in the extracts by comparison with the starting plant material. So now I usually refer to the total contaminant load, which is everything added together, which we're frequently finding 50 to 500 ppm. So by law in Oregon, if you add all those 59 contaminants together, the maximum can be as much as 25 ppm, which is still high in my opinion, but that's the law for the time being. So all of these levels are clearly health risks to users. It would be best if we could just get rid of all of them, which is what my goal overall is. Now, state authorities have already begun to mandate action levels for the specific pesticides, and eventually the federal health authorities will follow suit once cannabis is decriminalized and put into a different class of material. So there is something else that people in the cannabis field need to know. The safe concentration of pesticides in food products, which in cannabis lingo in the cannabis field are edibles, is established and well known, and it's actually a relatively high level. But the safe concentration of pesticides in cannabis cigarette smoke or the vapor of vape products, it's simply not known. Nobody's ever tested for it. However, during the partial combustion, pyrolysis occurs, and numerous products can be and are generated, just like they are in tobacco cigarettes. And many of these products are toxic. For example, myclobutanil, a heavily used, widely, very common fungicide, generates for sure a cyanide radical, which is definitely toxic. So this is not a trivial problem. Oregon decriminalized cannabis in '73, and effectively they were the first in with serious regulations of cannabis extract. And they have the most experience in regulating cannabis and cannabis extracts. And the bureaucratic maxim is do what the other guy did. So most states are following or will follow Oregon's lead. So today, in 2018, Oregon requires testing of cannabis products before they are sold. At this time, they are the only state to require testing. Though it appears that there is legislation in the California state legislature that is going to change that soon. And by the way, they're following virtually the same list of pesticides and contaminants that Oregon is using. They've added a few and deleted a couple of others, but they're basically the same. So the first in was Oregon, like I said, and then in '75, Alaska, California, Colorado, Ohio, and Maine decriminalized marijuana. Minnesota the year after that. Unsurprisingly, Massachusetts legalized in '77, but surprisingly, Mississippi, of all places, and North Carolina decriminalized in '77 with Nebraska after that. Those states collectively are what's known in the cannabis world as the first wave. Now, the rest of the states have followed since 2001, and the current status is that 31 states, and this includes D.C., have medical marijuana laws that permit its use. 20 of these states have operating dispensaries. 9 of the states have recreational marijuana laws, and 4 have operating retail stores. So what is being regulated? Exactly. Okay, so the Oregon Health Authority's technical report, 8964, which you can easily get on the internet. It's easy to get it. There are 59 contaminants being regulated. And note that, and this is important, synergists are not toxic by themselves, even though they enhance the effect of pesticides on insects. But they still must be, all these must be tested in cannabis and cannabis-containing products before they can be sold. So this is not a trivial problem for people in Oregon in the cannabis world. So the action levels range from 0.2 to 2 ppm, depending on the contaminant. Now, there are thousands of pesticides registered at the UPA, which is the agency that administers FIFRA, but only 59 are tested in Oregon. But the other, like I mentioned before, the other states will probably follow their lead. Now, additionally, you have to test for the usual residual solvents, which we're going to get into that in just a little bit. So, and here's the list of substances. I'm not going to attempt to go through all these one by one. Just note that these are all well-known substances, heavily used, which is why they're being regulated. So now, of course, a lot of people are probably saying, is this a real problem, or is this just bureaucrats inserting themselves into our lives? Well, if you look at the concentration of pesticides that you can buy at the grocery store, Home Depot, garden centers, wherever, that you use to spray if you get ants in your house or roaches or whatnot, you'll see that they're generally a maximum of 0.05%, which is 500 ppm. Now, if you look at the concentration of pesticides in the cannabis extracts, you'll find that they're just the same. So I don't think it's a good idea to have such high levels of pesticides in, cannabis products, and neither do the health authorities. So this is a repeat. The initial test results from a test lot of 7 kilograms we were working with and decontaminated, the total contaminant level was 100 ppm. And this lot failed. So the question, is this a real problem? The answer is yes, it is a real problem. So there's another little problem that people in the field should be aware of. As of 2016, Oregon had 420 dispensaries, 50,000 growers, 36,000 sites, and only 34 labs, and we got this from the Oregon government. So this is a major bottleneck. There is an insufficient number of testing laboratories. So this is going to be a problem for people going forward. So what can be done about all this, the general problem? Well, first, let's evaluate the methods to eliminate contaminants. Now, the first method, and it seems the easiest, is to simply grow your crop without pesticides. Right. Sounds easy enough, right? Just don't use pesticides. But in fact, it's not as easy as it sounds due to the persistence of contaminants in the soil and contaminants applied to adjacent fields. Also, contaminant-free water must be used, which requires a not insignificant capital expenditure on equipment and a high cost of production in the required volumes for the farmers, which you're going to have to convince them to grow cannabis instead of growing blueberries or cherries or wheat. So the second method to eliminate these contaminants is selective extraction. However, in reality, this is a myth. All solvents extract a relatively broad range of substances, and substances with similar characteristics are always extracted together. So if your initial cannabis plant material has toxic contaminants, no matter what solvents you use, then your extract will have some of the same contaminants, actually have all of them, and at a higher level than the original plant material, because they have the same properties. Contaminants and cannabinoids have the same properties and are extracted together. So another method is to use adsorbents and to do selective adsorbents. There are selective adsorbents, and we're going to explore this in some detail, actually a lot of detail, over the course of this series. So there's also chromatographic purification, and by purification I don't mean the isolation of pure THC or CBD or THCA. I mean the elimination of the contaminants. So, and this will work. It does work. We've done it, but you have to have experienced people and the right equipment, just to mention the right consumables. And we're going to explore this in some detail in this series. So, the last method, which is the destruction of contaminants by a chemical reaction. And this is not as difficult or painful as it sounds, or dangerous. It does involve the transformation of functional groups required for biological activity, such that the biological activity, in our case the pesticide action, is gone. The reaction must transform the substance into a non-toxic entity, and this is actually fairly easy to accomplish, but, and this is an important but, the chemical reaction must also leave the substances of interest intact. Cannabinoids in our case, and this can be done. We did it, and I'm presenting you the results, some of the results today. We're going to look at this in some detail. So, looking at the case of selective adsorption, there's a lot of adsorbents out there. Everything from alumina to zirconia, literally A to Z. Everything from ion exchange resins to charcoal the clay, everything. There's a lot of stuff that you could use, but we need to figure out which ones we do you want to use. So we have to apply criteria. First of which is the cost. It must be cheap. You may be able to get it. You got to be able to get rid of it. It's got to be sufficiently efficient that you can afford it, and preferably it's either regenerable or reusable, at least for a certain number of cycles. It's got to be, it must be selected, and it's got to either selectively retain either the contaminants or the substances of interest, and finally, it must have sufficient capacity to be useful. So, if we apply those criteria to all those absorbents, the absorbents that pop up, that pass all the tests, that go through the funnel, are fluorosil, activated alumina, silica, bonded phase silica, and polymeric adsorbents. Excuse me. All the other potential absorbents fail one or more criteria. So today we're presenting results with fluorosil, and studies with other adsorbents are ongoing and will be the subject of future presentations in this series. And we'll look at silica gel, bonded phase silica gel, polymeric adsorbents, both of which we're going to look at both reverse phase and ion exchange, as well as activated alumina. So looking at the case of fluorosil, what you do is you dissolve your extract in an alkane solvent, such as butane, pentane, hexane, heptane, isooctane, and pass the mixture through a column filled with fluorosil. You you add it to the column, pass it through, pass about 5 column volumes more of solvent through, recover it all, evaporate the solvent, and that's it. You're done. Now, which alkane do you need to use? Well, the Food and Drug Administration, the United States Pharmacopoeia, the United States Environmental Protection Agency, the European Pharmacopoeia, the British Pharmacopoeia, and just about every regulatory agency in the human universe recognizes 3 classes of solvents to assay in residual solvent testing. First, there's Class 1 solvents, and in their language, these are solvents to be avoided. This includes benzene, carbon, tet, and the like. Usually these are very toxic solvents and sometimes carcinogenic. The acceptable limits are usually in the 2 to 100 ppm range. And Class 2 solvents are, in their language, to be limited, which includes hexane, chloroform, acetonitrile, and a bunch of other solvents. So the Class 3 solvents are regarded as less toxic and of lower risk to human health. This is their language. Acceptable limits are pretty high. Heptane, for example, is a Class 3 solvent and has a limit of 5,000 ppm or 0.5% in the final product. Now, usually they're referring to a pharmaceutical product. For this reason, but only for this reason, heptane is the preferred solvent for cannabinoid extraction and in general for working with cannabinoids, purification, or elimination of contaminants. Now, what we did was we took our initial sample, which I already showed you the results, and there's about not quite 100 ppm of the total contaminants. The total contaminants are listed on the y-axis, and on the x-axis is the ratio of the extract to the amount of fluorosil. We kept the amount of fluorosil constant and increased the amount of cannabis extract we passed through it. And you can see that at about 12.5%, we got 98.2%. And that as we increased the amount of cannabis extract, we decreased the amount of contaminants that we eliminated. So, and this is the same information in a tabular form. We eliminated 98.2% of the contaminants using this ratio. Now, it's important to note for people who might want to duplicate this work that the dilution ratio, how much extract per amount of heptane we used, was 1 to 1 For example, we use a kilogram of extract to a kilogram of heptane. Now, that's about 1,200 milliliters of the heptane, in fact. Now, we tested higher dilutions, 1 to 2, 1 to 3, 1 to 4, and several others just to test, and the results were superimposable. So what the dilution factor is really didn't play much of a role, though we thought it might, which is why we tested it. So it's important to look at these results. From that original sample, the biphentonate is highly reduced. It's reduced down to about 1 ppm, but it still didn't pass. So the biphenthrin was slightly reduced and did not pass. And all the other contaminants were completely eliminated. This is only with fluorosil. And I want you to note, and you'll understand why I want you to note this now, the pyperenyl butoxide, the synergist, was completely eliminated using fluorosil. So an extract of cannabis diluted with an alkane can be passed through a column of fluorosil at a ratio of 0.125 to 1. And so far, we found the total contaminant load will be reduced by greater than 98%, and the recovery is virtually 100%. You always lose a little bit during handling, but we found that to be less than 1%. Basically, all the cannabinoids were still there. But just remember that not everything was eliminated. It depends on what you have in your original extract as to whether you want to do this. So we got to look at the cost of it. If it's, it's great, but if it's too expensive, we can't use it. So how much does it cost? So we're looking at two cases. First of all, with the PR grade of fluorosil, which is the pesticide residue grade of fluorosil, at a wholesale cost of $160 a kilogram, using the fluorosil only once, recovering the solvent and reusing it, including labor. I just used a general figure of $50 an hour cost to the company. The total cost of processing 1 kilogram of cannabis extract is $1,450 a kilogram, about. However, if we do that for 10 cycles, that drops to $300 a kilogram. But that is an assumption we are currently verifying and will be addressed in the next presentation in this series. So let's look at the final case, which is the destruction of contaminants by chemical reaction, which, and the first question you ask is which functional groups can be attacked? Well, what do they possess? You have all kinds of functional groups: carbamates, carboxylic esters, nitriles, organophosphates, oximes, phosphorylacetamides, and there are lots of other groups. Now, one thing that they all have in common is they're all highly polar groups, and they're all easily attacked by a variety of agents, particularly nucleophiles. So let's look at the functional groups of the cannabinoids. Now, what we have in cannabinoids, I put 3 representative cannabinoids up there, is phenols. A lot of them have phenols. Basically, they all have at least one phenol. They have an alkane group. They have an aryl alkyl ether. They have alkenes. They have aromatic rings, and some of them have carboxylic acids. That's it. So, and in general, they're very stable substances. Once they're made, they're pretty stable. They're all very lipophilic, very nonpolar. Most are not soluble in water. The carboxylic acids are. And they all possess functional groups that are not easily attacked by most common reagents. Now, we have developed a proprietary procedure that is easy to perform without horribly expensive equipment, and the approximate cost is about $200 per kilogram of starting cannabis extract with 99+% recovery of cannabinoids. You're not going to lose much. It ain't going to cost all that much, and you're stuck with this bad batch anyway, so you got to do something. Now, the cost I calculated includes the labor, reagents, and the solvents if you purchase the reagents and solvents in bulk, and absorbent-based cleanup also purchased in bulk. I did not include, because it varies too much, building costs or capital equipment expenditures such as equipment costs. For more details and licensing, please contact us at Sorbent Technologies. So, ignorance is bliss. In the past, there were no regulations and no testing. You started off with what you thought was good material and sold it as is, or extracted it to make a concentrate, and they both looked good. But in reality, you were wearing blinders. You weren't seeing what was there. Unfortunately, they were not good. You just thought they were. So you're going to have to do something. Reality bites. More and more often today, with regulations either here or on the way, cannabis tested products are tested and found to be contaminated with toxic agents. So you start with bad plant material, and it gets even worse when you concentrate it. Now, one thing that can catch you is that you can test your initial raw plant material, and it looks okay. But after extraction, the extract is found to be contaminated with toxic agents, and it's not good. For example, this is a very relatively common case, plant material which has malathion, a commonly used insecticide, with a concentration of 0.1 ppm, and the product is good to go, sell as is. But after extraction, the concentration of malathion increases by a factor of 10, and the extract now has a concentration of 1 ppm, and this is not good. You can't sell it. So the way forward is to take your plant material and test it. It could be good or it could be bad. And then after you extract it and distill it, not everybody needs to distill, but a lot of people do. The test results from your testing tells you if you need to purify, because you may not need to, and if so, which procedure to use. And then if it's bad, you have to purify it. So, and then to get your final product, which is good to go. So, a little bit more details. You start your plant material, could be good or could be bad. After you extract it and distill it, you test the extract. I did this in a standard decision action box. If it's okay, you got a final product and you're good to go. If it's not okay, you can do this chemical procedure I was mentioning, and then an absorbent-based cleanup, sometimes only an absorbent-based cleanup. And then, of course, you're going to have to distill it anyway to get rid of residual solvents so you get your final product, which is good to go. So, coming to a theater near you in the near future, based on our experimental results, which we are continuing to generate, we will construct a diagram with which a cannabis producer can take the analytical test results and know which procedure or combinations of procedures to use, and assuming he needs to use any at all, to completely eliminate any and all pesticide residues in cannabis products. Stay tuned for future developments. You can keep up with this at sorbtech.com. So thank you very much for attending, and now turning it back over to you, Meg.
Thank you both for such informative presentations. It's now time for the question and answer session. As a reminder, you can submit questions by typing them in the Q&A box, which can be found on the right-hand side of the presentation window. We'll try to answer as many questions as we can. Our first question is, if you use another solvent instead of heptane, can you get rid of the remaining contaminants in a second round of absorption?
We will be testing that. So far, we've just done one run-through. Well, I actually have some results, but I'm not ready to give a definitive answer yet. I'm not going to give results until I know for a fact for sure. So the answer to that is maybe.
Okay. What is the amount of heptane that we need to add to the oil to achieve optimal decontamination while maintaining an ideal flow rate?
As long as you add enough heptane to dissolve it so that you can add it to the column, that's good. That's generally going to be about 1 to 1. Some extracts are more oily, some are more semi-solids. I mean, you have to dissolve it in the heptane so that you can actually add it to the column. But if you add a lot more heptane, you're just simply got that much more heptane to eliminate at the end, and it doesn't, after recovery of the at the end of the solvent, you've got to eliminate the heptane. And if you dissolve it with too much, well, you're just going to multiply your work for no reason, because we found that increasing the amount of heptane just increases your work at the end. It doesn't change the amount of pesticides, contaminants that were eliminated.
What was the name of the lab in Oregon that you were collaborating with?
It's Cascadia Labs in Portland, Oregon. I'm sure you can find them on the web. So I don't know what their address is right offhand, even though I've corresponded quite a bit with them. And by the way, you can always call us at the number on the screen or send a letter. You can tell I'm an old guy. I called it the letter. Send us an email at cannabis@sorbtech.com.
Is the reagent technique available today?
Yes. Contact us, and we'll talk to you about it.
Do you have any experience with centrifugal partitioning chromatography?
I know what it is. I've used it a little bit. What you mean is I know what I know what it is. Yes, and I've used it a little bit in the distant past.
Did you?
I have not used it. Go ahead, Meg. Sorry.
Did you gravity feed the column or use pressure? And if you used pressure, what was it?
Oh, well, we used flash columns that we packed in-house, and we passed them through the pump at a not terribly high rate, but fast enough to get it through. So, it wasn't, I think it was 30 or 40 mils a minute, something like that, for, it wasn't too fast, but, I mean, we didn't, we want to finish the work, not spend all day passing it through. So, and this is, the fluorosil, is really just an adsorbent. So as long as it's got enough time to have some contact with the fluorosil, the contaminant is going to be absorbed. You don't want to pass it through too fast, because then, kinetically it won't have time to be absorbed. So anyway, that's, I think, a good answer.
Okay. Prior to adding to the column, are there any recommended sample prep or filtration steps commonly used?
Well, I don't know if commonly would be. I mean, we're trying out these processes for the first time. You want to make sure everything's dissolved. I mean, you don't want to have big clumps of stuff. But other than that, I mean, you're basically just adding these dissolved extracts right onto the top of the column. And for the chemical procedure, everything dissolves. You do the chemical procedure, and then you do an absorbent-based cleanup. It's pretty easy to do. So there's no particular sample prep involved. I mean, other than making sure you don't need to filter it. This is prep scale, purification. This is not analytical.
Do you plan to work with the California list in the future, and do you believe this will work for that list?
Yes, I went through it a week or two ago. They added a couple of them. I can't remember which ones they added. The California list and the Oregon list are not identical. They're close. The main pesticides, the most commonly used pesticides, are on both lists. And the ones they added are, I'm not really sure why. I mean, we're talking about bureaucrats here. They don't have to have a reason, so, the lists are not identical, but they're nearly identical. I think there's 45 that are the same. 45 out of the 59, no, wait a minute, that's not right. It's 48 of them are the lists of California and Oregon are the same. So The main thing is not what they put on the list. We have to have somebody that can assay for it in our tests. So, we'll probably test for those extra, and if you're going forward, we'll test on there. But testing is not mandatory in California, not yet. So, Oregon is our main focus right now.
What scale has this been run at?
We've done it at several hundred grams. I normalized everything to kilograms. We're going to be doing up to 10, 20 kilogram lots at a time in the near future. I mean, we're working with people that have contaminated lots, and if we don't do something, they get to throw them away. So they're more than happy to work with us.
What is
they
your
have barrels
method of
and stuff.
Okay,
sorry, go ahead.
It's okay. What is your method of washing or regenerating the fluorosil after the adsorption procedure?
Well, we haven't tried to do that yet. I'm pretty sure that if we just wash it with methanol and then dry it out in an oven, that's probably what we'll do. My main concern is the way I'm going to test the number of cycles that can be used is to take 100 grams of fluorosil and pass, the appropriate amount, make the 10 vials and pass it through there and find out how many times I can pass, how many 12-gram lots I can pass through there before the fluorosil stops absorbing. So this will be the subject in the future, right? And then what I'm going to do is I'm going to regenerate that by the method I described. Pretty sure we can regenerate it. We know the manufacturers, pretty well. I'm going to talk with them tomorrow, as a matter of fact. So we're going to find out exactly how many times it can be used. But I'm not prepared to make a statement on that yet because I haven't done the experiments yet.
Okay. This question might be related. You might have just answered it. Have you tried regenerating the fluorosil using a stronger solvent to elute the contaminants, or is the fluorosil just spent at some point by polar plant co-extractives?
Well, I'm pretty sure that if you run through methanol or some other very polar solvent, all those contaminants are just going to wash off. So I'm pretty sure that we'll be able to regenerate it. The question is, do I have to regenerate? Do I have to dry it out and heat it up to truly regenerate it? But that's a question I'll answer later, once I've actually done it and am certain of my answer.
Okay. How do you clean up the reaction mixture with your reagent-based cleanup method?
Well, give us a call and we'll tell you all about it.
What is the particle size of the fluorosil?
The particle size of the fluorosil, it's less than 100. It's 60 to 100, I think. 60, 100 mesh. Right. You can look on our website for the exact one.
Okay.
It's the PR grade, which has a defined particle size. Sorry, Meg, go ahead.
It's okay. What is the effect of temperature on the adsorption efficiency?
I haven't measured it. These are all being done at room temperature. I mean, it's not freezing, and it's less than 30 degrees centigrade and more than 10. It's basically room temperature, which is how all these things are going to be done anyway. There are no special conditions. I'm not heating anything up, and I'm not cooling it.
How much does cannabis extract get lost in the column? Do you use any washing step after you pass the extract through?
Well, we load it onto the column, and then we put in about 5 column volumes, and, our yield is essentially 100%. We can't measure any difference in the recovered weight. Remember, we're removing, a half a milligram or a couple of milligrams per kilogram of these, substances. So, you're not going to be able to notice the difference in the weight. What we do know is the weight is virtually the same. If if I put in 100 grams, I'm going to recover 100 grams. Sometimes we have a little solvent in there, that actually makes it look like you created matter and you have much, but that's actually just solvent. And once you heat it up and really eliminate the solvent, that goes down, and it's virtually 100%. And by the way, wait a minute, Meg. We had these assayed for cannabinoid content, and they were the same percentages, right? So, and we had recovered about the same weight. So, we didn't destroy the cannabinoids or lose them during the process. Now, go ahead, Meg.
Okay. Can large systems be built to handle large amounts of cannabis oil, such as 500 kilos a day?
Well, 500 kilos a day is quite a lot. I don't know anybody that's working at 500 kilos a day. We're working with people and scaling this up to the 20 kilograms per day. But this is a standard chemical engineering thing. I see no reason why we couldn't handle 500 kilograms a day. This is just that's an engineering question. Once the chemistry is known and it's known to work, and is known to work at a lab level, then a pilot level, then a production level, then at a factory level, you can scale it up fairly straightforwardly. But that's I bow out when we get past the pilot stage, and 500 kilograms a day. That's chemical engineering.
Okay.
But the answer is yes, it can be, I'm sure.
Okay. What is the comparison of results of chromatography versus chemical destruction?
Wait a minute. Repeat that question again.
What is the comparison of results of chromatography versus chemical destruction?
Well, that's kind of in there. Chemical destruction will get rid of most of it. And, but there's some things we couldn't get rid of with fluorosil that I can get rid of with chemical destruction, and there's some things that I can't get rid of with chemical destruction that I can get rid of with and vice versa. And I have yet to use silica or for this project or at least not very much. I'm not prepared to talk about that yet because I don't have enough results that I'm sure of my answers. So I'm not going to give partial answers or, what is that those financial people call it? I'm not going to make any forward-looking statements, So if I say it, it's true. That's it. So I'm not prepared to talk about that just yet.
Okay. Are you concerned that growers who skirt regulations will use this method to get cannabis that has been purposely grown with high levels of pesticides to pass regulations?
That's possible. Anything's possible. Look, it's been unregulated for, since the 1930s. It's an underground business that's, starting to come out. I'm providing a method by which consumers will get pure products. And frankly, I don't give I better not use the word I usually use. I don't care if they use this to increase their crop yield, increase their product. What I care about is consumers getting products that are pesticide free. That's it.
Mm-hmm. Okay. Have you explored any partnerships with anyone in Massachusetts? I know one of the biggest holdups getting dispensaries ready is getting the proper third-party QC testing.
No, we have not. That's actually a commercial question. Have we explored any partnerships with anyone in Massachusetts for testing this method? And the answer is no. We work with some people in Massachusetts, but in other areas, not in the cannabis area. So we work with the people in Oregon because we know them. It's legal to work with there, and there's no problems. I'd like to work with it here in Georgia, but I don't want to go into the hands of the Georgia State Department of Corrections. Thank you. Anyway, next.
What is the cause of the diminishing pesticide reductions as higher oil loads to fluorosil are used? Is the fluorosil saturated at that point?
Well, yeah, obviously. There's a certain number of active sites, and once those are taken up, then the others just pass through. I mean, that's, and it follows, it's not quite linear, but you can see that got a typical, if you look at the graph closely, it's got basically an exponential, it's got a typical S growth curve, or close to it, So, actually, I did test it, lower concentrations, about 98 to 99%, seemed about the right. I mean, if you use higher dilutions, less and less extract, then the fluorosil becomes uneconomical. And so I didn't test, what happens if you tested at 1% loading on the fluorosil, 10 grams of 10 grams of extract per kilogram of fluorosil. I mean, that's not economical. So I didn't test that, for those reasons.
Is the reagent method replacing or done in addition to fluorosil?
It's going to depend on what you have. I mean, I'm not quite at the point where I can make a chart. It depends on what's in your initial sample. If you don't have pyperenol butoxide, so far the only method I've found to get rid of pyperenol butoxide is fluorosil. But if you don't have that, then you can use one of the other methods. Maybe I'm not sure about silica, alumina, reverse phase silica, or reverse phase polymeric yet. I mean, actually, I do have a number of results, but I'm not. I got more testing before I say stuff.
What is the cost of initial supplies you would need, like pumps, columns, packing material, etc.?
Well, the cost is going to vary according to what you have, and depends on what state you're in. These are not high-pressure HPLC pumps. They're not going to cost you $25,000 a piece, to run these purification columns, right? On the other hand, they're not free either. So, but you're also going to have rotary evaporators. You're going to have fume hoods. You're going to have chemistry handling equipment. And you've got to have a working lab. So I can't. This is too general of a question for you to give me a specific answer.
Okay. Are the terpenes being recovered at virtually 100% through the fluorosil column cleanup?
The terpenes. Well, cannabinoids are diterpenes, so yes, they are. And I assume that what you really meant was the sesquiterpenes and the monoterpenes. And those are substances that most people want to get rid of. Now, the monoterpenes are mostly gone at the level of the distillation before the extract even gets to me. Before you want to do that, because when you distill it, the low molecular weight, more volatile monoterpenes just go straight out and you get rid of them. So most people are not concerned at that level. Now, if you're talking about just a raw solvent extract where you just take your materials, soak it in heptane or chloroform or dichloromethane and just evaporate it, yeah, that's going to have a lot of terpenes. I haven't tested for that. People aren't too worried about that. Most of those terpenes don't have a lot of biological activity in the first place. They just give it a certain odor, that's all. So, or at least the ones in cannabis.
Okay, I think we have time for one more question. Have you validated this method by spiking all the contaminants on the list?
Some of it, yes. I mean, the fluorosil one, yes, we have. And we'll talk about this more in detail in the next presentation. I mean.
Okay, great. Unfortunately, we're out of time. If we didn't have time to answer your question, someone from Sorbtech will get back to you directly. I want to thank the audience for attending and for participating in today's event. I would also like to thank our sponsor, Sorbtech, for making today's educational webcast possible. Please take a brief survey at the end of this webcast. Today's webcast will be available for on-demand viewing through July of next year. You will receive an email from LCGC and Cannabis Science and Technology alerting you when this webcast will be available for replay. We invite you to forward that announcement to your colleagues who may have missed today's live event. We look forward to seeing you next time. Goodbye.